Okay, we're going to take a look at distance formula and midpoint formula today. We're going to start off with the distance formula. Here's your distance formula. It's basically the difference in the two x coordinates squared plus the differences in the two y coordinates squared added together underneath your square root. The distance formula is really just a variation of your Pythagorean theorem. So now all we're going to do is plug in your x values. Now this first x value corresponds here. The next one corresponds here. And so you're just plugging those in. And then you're going to do the same thing for your y values. Plug those in. Take the corresponding y values here. And then plug in your other corresponding y value. And now all we have to do is simplify. And then we get the square root of 125. Now I'm hoping you're not going to leave it like that, since the square root of 125 simplifies. Square root of 125 is 25 times 5, so you can take the square root of your 25 times the square root of your 5. The square root of your 25 is your 5. Square root of your 5 you can't do anything with, so it simplifies down to a 5 root 5. Midpoint is really just the average of the 2 points, the point that's in the exact middle. So you're going to average the two x coordinates, which means you got to add them together, divide by 2. So you're going to add these two x coordinates together, divide by 2. And so then you end up getting a 19 over 2. If you wanted to write that as 9.5, because it can be written as a nice, neat decimal, you can. Add your two y coordinates together. Your y coordinates, once again, are the first one here and your second one here. That gives you 0 over 2. 0 over 2 is 0. So if you wanted to write this once again as a 9.5 comma 0, you could. That would work. Wouldn't be a big deal. So now we want to find the perpendicular bisector that goes between these 2 points. Perpendicular means it needs to be forming a right angle compared to the line that connects these two, and it needs to cut it in exactly half. There's two ways to do it. One way from geometry, you just set the distance between your unknown point of xy. So you'd have your point of xy, and you look at the distance between the first two here, and that's what we have right here. You look at the distance between the second two, this one and your unknown point, and that's what we have here. And all you have to do is go ahead and solve that. So you'd square both sides, then you'd have to FOIL that out, FOIL that out, FOIL that out, FOIL that out, collect your like terms, and solve it for y. Some people don't mind that, but there is another option for you. Since it's a perpendicular bisector, it needs to go through the midpoint. Well, you go ahead and you add your x's, divide by 2, and you get 1/2. Add your y's, divide by 2, and you get negative 7 over 2. It also has to be perpendicular, so the slope has to be the opposite reciprocal of what goes between these two. So you find the slope that goes between these two. You know the slope is rise over run, or change in y's over change in x's. So you take this y minus that y over this x minus this x. Then you go ahead and simplify that, and you get negative 1/9 for your slope of the line that goes between these two. But we're looking for perpendicular, so you know that your slope has to be the opposite reciprocal. Reciprocal means you flip it upside down. Opposite means you change the sign in front. So you know your slope is 9. So now we have a point and we have a slope. We could use our point slope formula to be able to go ahead and find our equation. We'll take our 9, plug it in for our slope, which is m. We'll take our y value of negative 7/2, plug that in for your y1. Take your x value of 1/2, plug that in for your x sub 1. And all we're going to do now is just get rid of your parentheses and get y by itself. You get rid of your parentheses by distributing through your 9. Then you'll have to subtract a 7/2 from both sides. And so then you end up getting y is equal to 8 or 9x minus 8, which happens to be the same answer we had doing it the other way. Well, one other thing that sometimes students struggle with is when you're given the midpoint and one endpoint, how do you find the missing endpoint on the other end? Well, the easiest way to do that is to go ahead and plot your points and then look at what's going on. In this case, we know C is your midpoint. So here's C, we have our midpoint. Here's A, it's one of the endpoints, which we have right here. Now you got to ask yourself, okay, if this is an endpoint and that's your midpoint, you know that you'd have to be going up this way. Your other point's got to be up here somewhere. Well, how far do you have to go to left and right from A to get to C? Well, if you're starting at 5 going over to 2, you're going to the left 3. So that means you got to go to the left 3 more to be able to get to your B value. So you know B has to be 3 to the left of that, which is a negative 1. And then you got to ask yourself, okay, how far am I going up and down? Well, I'm starting at negative 7, going up to positive 3. So that's 7 below to 3 above. That's a rise of 10. So now I got to start here and go up another 10. Well, 10 onto my 3 is a 13. So my other endpoint has to be negative 1 comma 13.